Hello everybody. With this course, we will try to give some basic information about electric current and its modulation. There are two opposite electric charges, namely positive and negative. The amount of positive or negative charge that the substance carries is defined by the number of unequal number of protons and electrons. If the number of protons are higher than the number of electrons, we observe we define the positive charge. If the number of electrons is higher than the number of protons, we call negative electric charge. An atom is neutral in nature. Hence, the material tries to go back to its natural state, which is the neutral state. If there is a difference in electric charge at 2 points on a conductive object, the substance tries to go back to its neutral state by displacing electrons from the point where the negative electric charge is higher to the point where the positive electric charge is higher. This displacement causes a force named as electromotive force, or in other words, electrical potential difference. The number of electrons displaced due to the potential difference differs with the conductivity of the object. Here we can say, or we are talking about some non-conductive materials such as rubber, plastic, high conductive materials such as metals. In conductivity, the number of electrons displaced in 1 second is defined as the current amplitude, and the resistance to the force that makes it difficult for the electrons to move is defined as resistance. Hence, we see that, or you know that, the resistance and the conductivity are inversely proportional. In presence of electric current, we observe some effects such as electrolytic, magnetic, and the heat which arises depending on the resistance of the conducting medium through which electric current passes. The conductive objects can be in solid forms, liquid forms, or gaseous forms. In liquid form, in liquid conductors, the conductivity is provided a displacement of negative charge to the positive charge through the anions, which has negative charges, the cations, which has positive charges. The formation of anions and the cations is provided by water-soluble salts, bases, and acids. The current, you are all aware of that. There are mainly two different current types. If the direction of the current is fixed, we call it direct current, which is also named in the literature as the monophasic or galvanic current. The current that does not change the direction for more than 1 second is physiologically accepted as direct current. If the current rises to a highest value, comes back to zero, value, then rises to negative highest value and comes back to zero value once again. We call this alternating currents. Since the current has the positive and negative highest values, such currents are also named in the literature as biphasic or Faradic currents. In alternating currents, there are some principal terms that we use, such as the periods, the frequency, the phase. Here, the periods, the time elapsed during the process, starting from zero, going to highest positive value or negative maximum value, coming back to zero, and going through the highest negative or positive process once again, is called as a period. The number of repetitions of each process in 1 second is defined as frequency. Here, the amplitudes starting from zero reaching to positive highest value, coming back to zero, reaching negative highest value, and coming back to zero. This is the process. The time that passes through this single process is called as periods. Here, starting from zero, going to negative highest and coming back to zero once again. We call this a phase, since the alternate current has two different phases, the negative and positive. It's also known as, or it's also named as, biphasic. Here, the amplitude is the maximum value. It can be positive or negative. And the frequency is number of repetitions in 1 second. Here we can talk about some, since we are talking about the number of repetitions in 1 second, we classify the currents in three different groups: low frequency, medium frequency, and high frequency. The currents with a high frequency, or the high frequency currents, has a frequency that is more than 1 million hertz. And the current sense is not perceived in such currents. In this type of current, the effect of heat and vibration comes to the front. Medium frequency currents. In this type of current, an asynchronous action is potential. If the frequency of the current is in between 1000 and 1 million hertz, we call it medium frequency, but usually in literature you may observe that 4000 and 20,000 hertz are widely used. Low frequency currents. In this type of current, the frequency is in between 1 and 1000 hertz. In common use, we observe 1 to 20 200 Hz. Most notably, Faradic, exponential, diadynamic, or transcutaneous nerve stimulation currents are examples of such currents. When we talk about the low frequency and high frequency, so for example, if we say this is the time that we are looking, number of repetitions defines the frequency. So when we compare these two currents during this period, during this time, in 1 second, the number of repetitions, as you can see, increase in high frequency currents. The alternating currents has positive and negative phases. It's biphasic. In modulation, we also see such effects. For example, biphasic application can be turned into a monophasic application that has only positive phases. This is a monophasic application. The current can be symmetric or asymmetric. If the current goes through the positive and negative highest values in a symmetric form, we call it symmetric current, or it may have different highest values in positive and negative phases, and it may be an asymmetric. In the current, the type of current application, the phase, can be triangular, can be rectangular, as we observed, can be in a sinusoidal waveform. Also, during this application, for example, in sinusoidal form, as we observed in previous slides, it repeats the maximums, or in negative form, it may have a different form. Hence, we will be talking about the modulation of the currents. It's possible to talk about three types of modulation in direct currents, which are intermittent direct currents. The direction of the applied current remains constant for not less than 1 second, and the current is interrupted at regular intervals, such as 50, 60 seconds. Such current type, intermittent direct current type, is most commonly used in denervated muscle stimulation. Reverse direct current is a type of modulation in which the current changes direction continuously, as in alternating current. The duration of each phase here is more than 1 second. In surrounded direct current, it's similar to the intermittent galvanic current. But the difference from intermittent galvanic current is the current amplitude is increased from 0 to the peak value in a few seconds, not less than 0.5 seconds. It may be in monophasic or phasic application. It will be sudden or slow reduction of the current from its peak value to the zero. In modulation of alternating currents, we observe three different types. It can be an explosive type of modulation, intermittent, or amplitude type modulation. In explosive type modulation, the passage of alternating current is interrupted for a few microseconds and lasts for a few milliseconds during the periods when the current passes. The alternating current modulation obtained in this way is also known as Russian current. In intermittent alternating current, it's a modulation type where the interruption lasts longer than 1 second and the current lasts for a few seconds only. The most obvious difference from the explosive type modulation is that it provides sufficient resting time for muscle relaxation after muscle contraction. In amplitude modulation, it's obtained by simultaneously giving two alternating currents with different frequencies to the tissue. In this way, two different currents are combined with each other to create a single current effect. It is also known as interferential current. The modulation of direct and alternating currents brings up the pulsed currents. The concept of pulsed current has been defined because the modulations have led to the emergence of new parameters in definition of currents and subsequently to the terminological confusion. It's possible to define pulsed current as the electrical current transmitted in the form of short-term signals. The parameters that determine the characteristics of these currents are current rise time, pulse duration, and pulse frequency. The current rise time, the time for the pulse amplitude to rise from 0 to the peak value, is the current rise time. Pulse duration, the time during which the minimum electrical energy required to stimulate the nerve is obtained, which is also equal to the chronaxia of the nerve to be stimulated. It can be between a few microseconds and a few milliseconds. Interpulse time, pulse frequency, which is the number of beats per 1 second or pulse per second. In modulation of pulse currents, we see the pulse modulation, the current modulation, the intermittent type, impulsive type modulation, and ramp type modulation. In pulse modulation, delaying accommodation is the main goal. The duration, amplitude, or frequency of the pulsating current automatically increases and then decreases. In current modulation, the current phase as a whole is modulated, not just the duration, amplitude, or the frequency. So, as a whole, we see a modulation. Three different types of modulation can be performed as intermittent type, explosive package type, and ramp type. The intermittent type, a few seconds of rest period followed by a current that lasts for a few seconds. In impulsive type modulation, A different application of pulse current in which the current transition and subsequent rest times are few milliseconds. In RAM type, unlike the intermittent pulse current, the current amplitude is gradually increased. It can be 1 to 5 seconds and gradually decreased. There is a rest period of a few seconds in pulse current as well. Here, if you look at the modulation in pulse currents, we can modulate the frequency repeating times. As you can see, the time in each repeatance can be varied. So the frequency modulation, the time modulation, in this case, the time for the current application gives us the time modulation. In amplitude modulation, the amplitude can vary. So in modulation of pulse currents, we may observe such modulations or combination of these modulations together. Okay, so we try to give some basic information about the electric current and the modulation. Good luck.